Last episode we learned OpenFOAM is a set of libraries, not a program you click. Today we install it and run something real.
The goal is simple, from nothing to a real simulation result in under 15 minutes.
No theory yet, just a win. OpenFOAM is built for Linux.
If you're on Windows or Mac, that means one of three paths. On Windows, WSL runs a real Ubuntu inside your system, the smoothest path, and the one I'll use here. Docker ships OpenFOAM as a container, identical on any machine, great if you hate setup. And if you're already on Linux, it's a single apt install, no wrapper at all. Here's the whole install. 3 commands. In PowerShell, first enable WSL and reboot. That single command installs Ubuntu inside Windows.
Then inside Ubuntu, update the package list and install OpenFOAM from the official repository. Finally, source the OpenFOAM environment so the solvers are on your path. Type simplefoam-help if you see the usage text, you're done. That's the whole install.
One caveat, the exact package name shifts between versions and distros, so match it to the official install page for your system.
OpenFOAM ships with hundreds of ready-made tutorial cases.
We'll copy the classic one, the lid-driven cavity, to our home folder.
Copy it, change into the folder, and list the contents.
There they are, the 3 folders from episode 0. We'll dissect them next time, today we just run.
Running a case is a pipeline. Mesh it. Solve it. View it. 3 commands, in order. blockMesh reads the geometry and builds the grid of cells. icoFoam is the solver. It marches the incompressible equations forward until the flow settles. Watch the numbers scroll, those are residuals, and we'll read them properly in episode 6. And ParaFoam launches ParaView to visualize what we just computed. And here it is. The top lid drags the fluid, a single big vortex forms inside the cavity. This is the result you computed. You didn't understand a single file to get here, and that's the point. You have a working simulation. Now you'll want to know why it works. That's the win.
Installed, meshed, solved, and visualized a real CFD result, start to finish. Next episode we open those 3 folders and name every file, so nothing about this case stays a mystery.
See you there. Last episode